Welcome to a new test and teardown video. This time it's an HEME International clip-on amp meter. And this one should be able to do both AC, DC. How about that? I think it's defective. It's classic. I get stuff like this for free because it just don't work. But let's see how defective it really is and what can we do about it. One of the first thing is that it does of course not power on. I think you do something like this and nothing happens. So of course the battery is flat, probably. But then there's also another thing. You push this clip opening thingy, and then I see there's like a rubber kind of, see? That one. And what do you know? This can't be right. This distance is definitely not how it's supposed to be. It's supposed to go all the way and touch metal to metal. Otherwise there will be a huge flux loss here. And then of course it's not going to measure anywhere near the correct current. So then there's probably something blocking this elastic or the spring kind of closing mechanism. So it's probably just a mechanical problem. So that could be cool if I can fix that. And maybe that's 100, maybe it goes to 100 amps. So that could be interesting. I haven't yet figured out how to access the battery, but I think that maybe one screw is looking different, and maybe this is, maybe there is some kind of a, this looks like, look at that. Maybe there's a battery in here. Maybe there's a 9-volt battery because it looks a little bit like that, right? And of course you don't want to take out 4 screws when you want to change the battery. So that will be my first experiment to release that screw. Of course I don't have a manual, and of course I don't care about manuals. This is what I do. Let's just try and think and see, can we figure this out? Yeah, maybe we can. Okay, so I was right. See, that screw releases this kind of side thing, and then there's a 9-volt clip. And I am so lucky to find a unit without a battery in it. That is definitely the best. All the times I find old units with batteries in them, it's not a pretty sight. So one more clue, please take out batteries. Wow, look at that. I put in a 9-volt battery, but there's a little bit of loose connections. So I put on some wire like that, and it's actually up and running. I think there's some sort of an auto zeroing kind of thing. After power on, then it goes to 0. And I put my wire, red wire goes through here, and the black one is not just connected to resistors like that. And now I will try and give it a little bit of DC. Let's give it 100 milliamps, 2, 3, 500. So that's 500 milliamps DC, and it says 0.2. Let me try and disconnect. Okay, so that is 0.2. But I think, of course, if this one goes to 100, then the first amp is probably not any good. So that is 0.5. Now it is 1 amp. Okay, and that is 0.7. So let's go to 2 amps. Okay, I have an idea. Let's disconnect. Let's try and go 2 amps negative. Okay. So that is how it is with low amps. It is probably a little bit off. See, that's my 2 amps. We can go to 3. Yes, that is 3 amps. No, it is not 3 amps. There's something to do with the voltage. I need to crank up my voltage. I'm a complete idiot. I'm sorry about that. Now we got 3 amps. Okay, 3 amps positive, and then 0 and 3 amps negative. Hey, now it works. Let's try again, 3 amps positive. Okay, so let's try and go down again. 1 amp. Okay, so yeah, it is 1 amp positive and then 1 amp negative. Okay, so there's a little bit of offset. And then let's try and do 1 amp positive again. Let's crank it up to 2 amps. Yes, now we got 2 amps positive. All right, so at least, and 2 amp negative, yeah. I think it works, but it's definitely not for super low current. But here is a trick. If you know you want to measure low currents, all you have to do is take your wire and make a few windings. See, if you want to measure 1 amp, I have an idea. Let me show you this. So look what I did here. I put 10 windings. Oh, this is bad. It's black wire. I'm so sorry, but that was what I could find easily. So that is 10 windings. And let me try and do 1 amp. And let's turn on the... See? And then it goes 10. So, and that was negative. Let's go positive. See how accurate I can now measure 1 amp. Now I get even decimals and stuff, right? All you have to do is do the windings trick. Let's see if it continues to be 1 amp. Yeah. So it really works, and it's super easy to gain the readout up like that. So now I am in here. That was super easy. Now it's actually a little bit easier to see what is going on with this switch. See, you can move it down 2 times, but you can't move it up. It's kind of locked, but you need to push this little extra release. See what happens if I release it like this? Then click, and then click. I mean, why? It's just an ammeter. There's no electrical connection to anything. It's not dangerous, or what the heck is that? Why is it made like that? I still haven't figured that out. Why this kind of safety super duper funkiness here? So this is the open mechanism. And I can't really understand why we're having this distance. I think I'm going to play a little bit with the current measurements and see if there is, if I can prove that it doesn't really matter if it is completely closed or not. I would of course expect it to lose a lot of its value, but I'm definitely going to do a little experiment with that. I've now figured out that there's definitely a lot of, see, loose connections. So there's definitely this is where all the problems, see? The more I move this, the better it seems to get. So here's my 0, and let's just try and see if it works again. I got my 10 windings, I got my 1 amp, okay, and then it goes to 10. Okay, so far, right? So all this is fine. And let me just take a little bit and see if I can create a tiny little gap, right? And then let's go with the 10 amps again. Aha, see what I'm saying? Let's do it the other way around. See? So this is, yeah, of course, this is my 1 amp times 10 windings, right? So let's try and give it double the distance here. See what happens again. Let's do it one way, see? Value is lower. And then that was the other way. So that is super important. So there is definitely a mechanical issue. And this is why I got those rubber bands. That is to push them all the way together. So there's something here that prevents this from happening. And then we got a little bit of loose connections, both in the battery connector. See, there's a funny hold up time. It's, see, then low bat and then it turns off. That is funny. Let me see how I can probably take it apart here somehow. Maybe there's a screw, or maybe there's let me have a look. Okay, so that is how it is held in place. This one actually just stands on this piece of foam, and this foam just presses up the display into the plastic casing. So that's kind of how it is. Slippity sloppity here, right? And then those two boards, they are soldered together at exactly the right angle. And here we go, some pins, and they are tinned into a socket that's also either tinned or I can't remember exactly what you call this surface treatment here, but this one is probably just tin. So I'll try and see if I can clean this up and see if I can get a more stable reading when I move it like that. So that is definitely one thing to do. And see, it's actually coated for humidity or moisture and all sorts of stuff. And there's a trimmer. So when you have everything assembled, you can remove this. Here is this release knob or release lever. So if this is out, you can actually access this trimmer for calibration, and you can also access the other 2, 3, oh 4, 5. We got 5 different trimmers here as well. Look at that. And then we got those 3. Oh, you can only access them from the top. Of course, we're not supposed to touch any of those trimmers because it actually works when it is closed correctly. But other than that, oh yes, that will be RMS conversion and all that kind of stuff. And then we also got a little connector down here for serial port or some stuff like that, right? At least that is what I think. And see, here's this switch. It's not doing anything. It's just this push release. I really haven't still figured out why is that a cool thing. But see, we got all those wires going in to the magnetic field, and there's probably also a Hall sensor for zeroing and for DC kind of thing. There are actually many different methods of measuring AC and DC current in a metal core like this. And one of the methods, the old ways to do this, is actually without Hall sensors at all. They just uses the magnetic saturation of the core. But I don't think this unit can do that with a tiny little 9-volt battery, because that requires a little bit more power. But I don't know exactly the design philosophy behind this unit yet. But I mean, that is kind of what there is to it. We got some op amps down here. I think, yeah, both of those, that will be op amps. So it's like all analog kind of stuff here. So what I will do now is I will see if I can figure out what mechanical problem is preventing these from closing correctly. So there are actually a few other things I wanted to show. That is the inside of this casing. I don't know if you can see that, but it's painted with some, can you see that? With some special electrical conductive paint, and that is of course to shield this entire, the circuits and all that kind of stuff to make it work when you're holding this without creating all sorts of hum and stuff like that, right? So it's also under here, and it's going to the 2 ground connections here, so everything is screwed together here and making a very good contact to that. And this handle here is of course free like that, so this means that this spring is what holds everything together, and the idea is of course that it will stop and then be pressed, so it's only touching those 2 points, right? but it kind of stops by just touching the inner part. See, here it is. I don't know if I can make this more visible with some more light maybe. But in here, see, this is the inside part of the metal core. And when that touches the other part, this static part, then it stops moving, and then there's still air gap here. And that is because there's something with this joint. See, there's a screw here. This is the joint, right? So it's kind of stuck there. It's supposed to be able to move more here, so there's supposed to be more slip slap here, and this hole is of course supposed to be quite big. So that means you can open it, but when you close it, it's not going to kind of stop in this joint and that point. No, it will continue and only touch those two metal points. This is where we want the force to be, and not this point and that point. There's no other places where it touches like plastic or any other thing. So I think we need to inspect this kind of joint here. It's probably just because we need to clean it from old dust and debris from wear. So that's probably what is causing the problem. But also, when I'm looking down this hole, I see another PCB. So there's one more layer of electronics. So how do I actually get in there? I see a connector here, and that's been glued. So if I need to take out this PCB, I will have some problems with the wires. But you see the white, red and black goes like this, and then yeah, there's a little groove here on the top on that connector, and then the three wires, they go here. So here's the black, so it's super easy to desolder. That's probably the idea. And the red one goes on this point, and then the white one goes on that point. So that is what you're supposed to do, and then just bend them to the side, and then you can pull out the PCB. At least that is what I'm going to figure out how to do. I got those three screws here, and I'm a little bit afraid of which one is actually connected to plastic, but I see a little tiny bend. I don't know if you can see this, but it is, yes, here you can see that. It gotta be that screw. So what I will try and do first is take this out and then see if everything comes out. So here on the bottom there is this extra PCB, and here we go. There's another connector here, and again it is tinned metal, and I think this is also a sort of a tinned ally on this connector, right? So that means the best would have been gold, definitely, and it's really nicely coated. And I see a little bit of modifications here. So this is a resonant circuit, I would guess, right? And then we got a lot of op amps. We also got this as a classic voltage, capacitive voltage step up, I guess, right? And yeah, the 4093. So I've been playing a little bit with the mechanical issues here, and it still is doing this kind of stops and don't touch here at the top. And that is because you can see here is half of the problem. Those are all cracked, so there's no mechanical hold on anything here, and that's because this is very, very old and has been pushed real hard for many years. And then on this piece of metal here, that actually is the hinge, you can see here is where it's hanging in this kind of, there's a piece of metal in here, and that is worn, so that is now further in, and now it stops on the inner part and is not touching on the outer part. So the way to fix this is to take this out, or move these all the holes, or make this like bigger so there's friction, so it will stop here and all that kind of stuff. But to be honest, I don't really want to bother, because I got other tools that's like 10 times better and more cool and more new and more sexy than this old thingy here. but that is how it could have been done if I had 1,000,000 hours in my life, or if this was the last clip-on amp meter in the world, I would probably save it. But honestly, I feel the work involved in fixing and moving all those kind of parts and changing all this is just really, really not worth it. And so that is kind of where I will just keep this as it is. We could maybe try and pull this out, because here is, see, it can be pulled out. Yes, definitely. It is coming slowly. In a second I'm gonna get hurt. At least it feels like that, right? Why is it not? So here we go. So this can't be the problem, really. Aha, look at that. I don't know if you can see this. If we look through the holes here. Oh, it's also cracked here. So if now it's touching both here and here, right? Look at that. This is the kind of, I don't know if this is visible on the camera, but it's definitely not in the sensor anymore. And this is the kind of the problem that we have to make this work. But it's completely cracked. It's probably been falling on the floor a few times, obviously. Too bad. But anyway, that was more or less what I wanted to show you. Yeah, here is, this one is quite alright. It is not moved, but it's something to do with all this, probably. Let's have a look. What is wrong with this hole? Nah. So it's all this that's kind of been bent. That is really odd. And the other part is also more or less the same kind of, but that feels like it's super duper firm. But if this has been bent as well, then yeah, there you have it. So that was this super nice amp meter. Alright, thank you very much for watching, and see you soon. Bye bye.